Hi, my name's Sean, and I did my machine learning project on predicting seismic bumps. I originally wanted to do my project on predicting earthquakes, but the I started the project and I didn't realize that a seismic bump is a little bit different. Um, but it's related. And the reason why I wanted to do earthquakes is because I'm from Seattle, and Seattle is has always been a really uh, prone to earthquakes because it's on the tectonic plate fault line of the Earth. Um, and I was in Seattle during the Nisqually earthquake, which was the last biggest earthquake that we had in 2001. And we're expected to have one at pretty much any given point. So I thought it would be interesting to make a classifier that would uh, be able to predict when one might occur. Instead, I'm doing seismic bumps though, and they're related because they're like earthquakes, but they're really difficult to predict. Um, but they occur in underground mines, and they can cause a bunch of issues with mining. Um, so my idea was I wanted to find the best classifier possible to be able to predict a seismic bump. Because if a seismic bump occurs, then it could be catastrophic, and people could die. Uh, it could be really expensive because of the damages. So it's I wanted one that would a classifier that would be at the absolute best in order to predict it to avoid all that kind of stuff. So I trained a bunch of different classifiers, and as you can see on this first graph right here, um, each bar is one of the classifiers, and each portion of the bar is one iteration. So I trained each classifier 6 times. So for each loop, it gets trained, and I randomized the data every time, and then I averaged out the scores to see which one would be the best overall out of these six. Um, Most of them are each iteration is more or less the same in terms of score. Some of them, particularly the quadratic discriminant analysis classifier, you can see some of these bars are a little bit smaller than the other ones. So this classifier was really inconsistent. So it would be pretty bad to use this classifier in order to train this particular data. Um, and then after I trained them the first time and averaged them out, I did it again, but the second time I used a grid search method, which is basically it is a way of testing a bunch of different hyperparameters in order to find the ones that work best for a classifier. So it's sort of like using an ensemble method, but I don't think it actually counts as one. Um, and most of the classifiers they all increased in their average score. It's kind of hard to tell because these graphs are pretty small. Um, because they didn't increase a whole lot except for the quadratic discriminant analysis one. Um, and overall, I found that for this data and out of all of the classifiers that I trained, that the random forest uh, scored the highest on average out of all these classifiers for this particular data set. So that was the classifier that I would use. Um, but if I were to do this again, I would want to do it a little bit differently because I would want to have more classifiers. I only use 6 of them, so there's a lot more that I could use that could potentially work better. And I would want to use some ensemble methods like bagging or boosting or voting. Um, the reason why I didn't use those is because I wanted to try something different. So that's why I used the grid search method instead. Uh, because it had a similar effect. It increased the accuracies. So in the future, if I were to continue this project, I would add some ensemble methods, and I would add some more classifiers, and I would hope that I would get better results. All right. Thank you for watching.